Okay, today we're going to work on quadratic functions, and particularly we're going to spend most of our time solving quadratics by graphing. General rule of polynomials: the highest exponent you have is how many answers you have, how many roots you have, how many solutions you have. So if I have x squared, I should have two answers, and you will have two answers. You always have two answers, even if it's one. That's a double root is what that one is. It's a perfect square. You have what's called a double root because it appears twice. So you always have as many answers as you have your highest power on a polynomial. Sometimes those answers are imaginary answers or complex, which we will get to later on. We don't deal a whole lot with those, but we do have those from time to time. You will not get those from solving by factoring. But you will always have as many roots as you have your highest exponent. The zero product property is the most important part of solving by factoring. It says if I have two things that when I multiply them I get zero, one or both has to be zero. Because the only way to get zero from multiplying is to have zero be one of the numbers. You can multiply any other number but zero, you're never going to get zero. But if one of the things you're multiplying is zero, the whole thing is. That's what makes this work. That's what makes this work. If you don't have this property, if this wasn't true, you couldn't solve these problems this way. Which means that when you're solving them, whatever you have, whatever you have, yeah, I'm recording, okay. Ax squared plus bx plus c needs to be equal to 0. If your quadratic is not equal to 0, you cannot solve by factoring. It has to be equal to 0 first. Some of the problems you will have are not equal to 0, needing to make them equal to 0 before you solve by factoring. Because otherwise it doesn't work. If I have x squared plus 3x equals 5, well, there are literally an infinite number of numbers I can multiply together to get 5. And so that won't work. It has to be equal to 0, or this doesn't work. You cannot solve by factoring otherwise. Okay. Now, the first two problems are a little bit different, but it kind of ties everything in together. So determine the quadratic equation given the zeros. When we're talking about zeros, and zeros are roots, solutions, all those things mean the same thing. Where are my solutions? Where are my zeros? Where are my roots? They're right where the parabola crosses the x-axis. If it crosses twice, those are my two zeros. Those are my two solutions. On this one, my solutions are -1 and +3. Those are my answers. Those are my roots. Okay. Now, I can use those to actually create the equation that gives me this parabola. Expression equals y, because it's equal to the graph. I need to do the parentheses. And I'll have x, and I'll have x, and then I'll have my roots inside. What have I always said about inside? Inside is opposite. Inside's opposite. So if -1 is one of my roots, what do I have inside? +1. If +3 is one of my roots, what do I have inside? -3. And you'll see more clearly why this works that way later on. Okay? That's my quadratic equation. X plus 1 times x minus 3 equals y. Now, we don't want it in that form. We want it in standard form. X squared bx plus c. That's what we want. So what do? FOIL it out. FOIL, first terms. X times x. Outside terms, negative 3x. Inside terms, 1x. And your last terms, negative 3 equals y. And then what do? Combine up the like terms in the middle. X squared minus 2x minus 3 equals y. That's what we're looking for on this one. That is the equation that gives us this graph. Okay? That's the equation that gives us this graph. Any questions on this? And I like this because it connects the graph, the roots, with the equation, with the factored form. There's a connection here. There's a connection between these dots here and these two parts here and this whole thing there. They are connected. 3 versions of the same thing. And it's nice to have that visual connection between everything that's going on. Because what we're going to do is we're going to go backwards. We're going to start here, go to here, and find these 2 points. I'm not going to make you graph it every time, but we're going to find those 2 points. That's what we're going to be doing most of today, which is mostly what you do when you're solving. You're looking for these points here and starting there. Okay? But first, you need to do these 2. Find the quadratic equation given the parabolas. Okay, so let's go ahead and do these. So I find my zeros. This is 1, 2, 3, negative 4. This is 1, 2. So I have x plus 4x minus 2 is equal to y. Foil it out. X squared minus 2x plus 4x minus 8 equals y. Combine up the like terms in the middle. X squared plus 2x minus 8 equals y. Same thing on the next one. Find my zeros. This one's negative 3. This one's positive 2. So I have x plus 3. X minus 2 is equal to y. Foil it out. X squared minus 2x plus 3x minus 6 is equal to y. Combine up like terms. X squared plus x minus 6 is equal to y. And that's what you should get. Okay. Questions? Yes. What do you mean, what am I multiplying? To get the foiling? Okay, so FOIL stands for what? First, outside, inside, last. So you do the first terms in each. So the first terms gives me that. The outside terms are the ones on the outsides. Gives me the second term. Inside, 4x, gives me that one. And then the last terms in each gives me that term. First, outside, inside, last. The other thing you can do, and I've done this, and I don't do it with when I have 2 and a 2, is I'll set up a box, and I will put the factors there, and then fill it in like a multiplication table. So you get x squared minus 3x, and then 2x minus 6. And then your diagonals are like terms to combine up. I don't do this if I have 2 in each term, but if I have 2 times like a 3 or a 3 times a 4 term one, I do this because it's a really great way of organizing. We're actually going to do more of this, I think, in the next chapter. I know we work on this more in the next, I believe it's in the next chapter. I don't think it's this one that we do that more. Okay. But yeah, if it's more than just 2 by 2, I always set up a box like this because it's a really great way of keeping your work organized. And that's the most important thing when you're multiplying stuff like this, because it's really easy to get lost in a hurry. And I've learned that the hard way. And when you get higher level math, you tend to get lost in a hurry if you get some big stuff going on. Okay, now solve by factoring. First thing, is it equal to 0? Yes.
Factor, you get like 2 things that are like 3 and 3. you divide that?
We'll get to that. We'll get to that. Okay. I'll say your first step, factor, you have to set it equal to 0. If it's equal to 0, go ahead and factor it out. I don't care how you factor it out, but this always works well. Setting up the X box like this. So I have -7 and -6. So that's -7 and +1 are my two factors. So I get x minus 7, x plus 1 equal to 0. This is the zero product property rule. This is where it comes in. This is why it's important. I have two things that I'm multiplying that equal 0, which means that each one of those things, the first factor equals 0, and or the second factor equals 0. That's why this works. If I have two things multiplying 0, one or both has to be 0. That's why it has to be equal to 0 in the first place. That's what factoring does. This is what it does for you. Makes it easy. And then you solve these. Add 7 to both sides, x equals 7. Subtract 1 from both sides, x equals -1. Notice, the solution is the opposite of what's inside. The solution is the opposite of what's inside. Because I set what's here equal to 0, the opposite of -7 is what makes this 0. The opposite of 1 is what makes this one 0. That's why inside is opposite. That's where this comes from solving these problems. That's the connection that you've done this before. Hopefully you saw that, but that's why the insides are opposite. Okay? Do the next one. Is it equal to 0? Yes. So you factor it. 30 and -11. 30, positive 30, -11, -5 and 6. Divide them both by 3, and I get -2 for this one. So I have y minus 2, and 3y minus 5 is equal to 0. My two factors. Y minus 2 is equal to 0. 3y minus 5 is equal to 0. Add 2 to both sides. Y equals 2. Add 5 to both sides. 3y equals 5. Divide by 3. Y equals 5/3. Okay. Work shown. Notice there's a difference between these two in the work shown. First example I did shows everything. It's perfect. It's got all the steps. Everything is there. If this was an Algebra 1 class, this is exactly what I would need to see. This is not an Algebra 1 class. This is an Algebra 2 class. You get to show one less step than they do. You don't have to show me the adding to both sides. Okay? I don't need to see this. Here's exactly what I need to see. I need to see the factored form equal to 0. I need to see each factor equal to 0. And I need to see the final answer. I don't need to see the X box, but if you have it there, that's fine. But if you have one like this that you can figure out without doing that, I'm okay with that. I'm good with that. Personally, I can do these just fine. When they get more complicated like this one, I do the X box unless I've seen it enough, I know the answer. Okay? So I need to see the factored forms equal to 0, each factor equal to 0, and the answers. Those three things need to be present. I don't care if you go, oh, I know what it is for this. I can go straight to here. I need to see each factor set equal to 0. I need you to ingrain that step into your head because that is the process, it's the concept that lets us solve this. Because we're not always going to do this with quadratics. You might do this with more complicated equations where your factors are not just x plus 1 and x minus 2 and that kind of crap. You've got like a square root and then x plus 1 and then maybe e to the x or some crap like that on there. You have to set each part equal to 0 no matter what your factors are. And you work on it with the easy ones, so when it gets more complicated, it's easier for you. Okay, bottom two. So this one is not equal to 0. Subtract 15 from both sides. A squared plus 2a minus 15 is equal to 0. Must be equal to 0 or factoring doesn't work. And then factor. Two numbers that multiply to give me negative 15 and add to give me positive 2. A plus 5, a minus 3 is equal to 0. If you need to set up the X box to do that, please feel free. Please feel free to do what you need to do to get it right. Okay. That means a plus 5 is equal to 0. A minus 3 is equal to 0. A equals negative 5. A equals positive 3. Now, the other one, the next one. It's not equal to 0. I need to set it equal to 0. Here's a hint. You want your squares to be positive. Factoring is very difficult if your squares are not positive. You want your squares to be positive when you do this. In order to make that work, I need to do this. I need to add 5a and subtract 3 from both sides. So I get 2a squared plus 5a minus 3 is equal to 0. Negative 6, positive 5, that's 6 and 1. Sorry, 6 and negative 1. Oh, wait, I did that wrong, didn't I? No, I did that right. Yeah. Divide those both by 2. And that gives me 3 for this one. So I have a plus 3, 2a minus 1 equal to 0. So a plus 3 is equal to 0. 2a minus 1 is equal to 0. A equals negative 3. And a equals 1/2. Add 1, divide by 2, you get 1/2. Okay. Questions so far? Okay, more examples, and these are important examples. So the first one, two y squared plus 7y is equal to 0. X box factoring is not going to work on this one because I need 3 terms. However, this is factorable. What do I have in every term? What's in every one of those terms? No. Y. I get a y in every term. Factor out the common factor. Pull out a y. Y, 2y plus 7 equals 0, your greatest common factor. If you have a common factor of, let's say, y in every term, you have a variable in every term, pull it out first. And I do have 2 things to set equal to 0. I have this times this, so y equals 0. There's one answer already. And 2y plus 7 is equal to 0. This is probably one of the easier ones, but students screw this up in several ways. One, they don't, oh my God, I can't pull out a common factor. They try to set up the X box and it just doesn't work. Or they do pull out the common factor and they forget to set the y by itself equal to 0. And then my other answer, y equals negative 7/2. This is a parabola. It will cross through those 2 points. The next one is also somewhat unique. It is the difference of 2 squares. There's no common factor, but I have a perfect square minus a perfect square. How do you factor that? N plus 3 and minus 3 is equal to 0, which means that n plus 3 is equal to 0 and minus 3 is equal to 0. So n equals negative 3 and n equals positive 3. 2 answers, 3 and negative 3. And if you want to get fancy, n equals plus or minus 3, which is still 2 answers, right? Plus or minus, 2 answers, plus or minus. The next one is also unique. Okay. I have a common factor. What is my common factor? 5. Do I have a variable that is a common factor? No. So if I have a common factor that is a constant, this is actually really nice to do. Just divide both sides by that common factor. Divide everything by 5. Right, you can do that, right? You can divide both sides by 5. Doing the same thing to both sides, it's still equal. If I divide this by 5, that means each individual terms divided by 5, I get x squared minus 2x plus 1 is equal to 0, because 0 divided by 5 is 0. And then I have an easy one to solve. 2 numbers that multiply to give me 1 and add to give me negative 2. What are the 2 numbers that I can use to multiply to give me 1? 1 and 1, right? There is no other choice. Whole numbers that multiply to give you 1 are 1 and 1. So this is technically x minus 1 times x minus 1. But what is x minus 1 times x minus 1? It's x minus 1 squared. This is a perfect square. If I have a perfect square, I don't need to set each one of them equal to 1. I can just set what's inside there equal to 1. Equal to 0. So x minus 1 is equal to 0. So x equals 1. And you're going, but Mr. Orris, you said if it was a square, if I had x squared, I'd have 2 answers. You do have 2 answers. 1, twice. It's called a double root. If you have a perfect square, that's how many answers are of that. It's called a double root. You've got technically 2 answers that are both 1. If you graph that, it doesn't cross the x-axis, it touches the x-axis, and x equals 1. Okay. Next one. At 7k, at 12, at 7k, at 12, 0 equals k squared plus 7k plus 12. I know a lot of students get upset at this one because, wait a minute. It's zeros on the other side. It doesn't freaking matter. As long as it's equal to 0, it doesn't matter which side of the equal sign the zero's on. This is the first one, the zero's in the front. It doesn't matter which side. Okay. Yes?
Sorry, is there a negative sign on the k squared? Should it be there when you rewrote it?
No, there's not a negative sign on there.
No. Like when you rewrote it, there should be a negative because you subtracted.
No, I did not. I did not subtract k squared. I added 7k and I added 12 to both sides because you want your squares to be positive. When you're doing your factoring and you're solving by factoring, you want your first term to be positive. If your first term is not positive, multiply through by -1 to make it positive. Because you can do it. It's really hard to factor if your squared term is negative. You can do it, but it's really not pretty. You don't want to do it. You want to have it be positive. That's why I moved the other two over. Yes, it's more work to move two things than one, but it's less work in the long run because it makes it easier to factor. So this one, 0 equals k plus 3, k plus 4. So k plus 3 is equal to 0, and k plus 4 is equal to 0. K equals -3, k equals -4. Like I said, you can do it, but you have to do the X box. It's not easy. It's much easier if your X squared is positive. Okay, next one. Common factor. What's my common factor? What can I pull out of both terms? 3m. I have a 3 and I have an m. Pull out a 3m. 3m times m plus 6 is equal to 0. So 3m equals 0. M plus 6 is equal to 0. So m equals 0. M equals -6. And the last practice problem. I have squared in one term minus a number, but they are not perfect squares. 2b squared and 98 are not perfect squares. However, they're both divisible by 2. Divide everything by 2. If you can divide everything by a common factor, it makes it easier, smaller numbers. B squared minus 49 is equal to 0. Now this is factorable. 49 is a perfect square. B plus 7, B minus 7 equal to 0. B plus 7 equals 0. B minus 7 equals 0. B equals -7. B equals +7. And those are your two answers. You know, I did a lot of example problems, but I wanted to hit a lot of different possibilities. Okay, a lot of different possibilities so you can see what you're going up against. Any questions? Yes?
When are you dividing them? Like, because for the one you had set 7 equals, or 7 halves and 0, -7 halves and 0. But for other ones, you just don't divide them. So,
Like
in example problem 2.
this one here? Or?
Yeah.
Yeah. Okay, so I get 2y plus 7 is equal to 0. Subtract 7 from both sides, and then divide both sides by 2. I just didn't show the algebra steps to get from here to here. If you need to do that, show it step by step. If you need to do, if you have 2y minus 7, plus 7 equals 0, subtract 7, 2y equals -7, divide by 2 to get y equals -7 halves. I'm okay with that. I'm okay with that. I'm not showing that step because you don't have to show that step. But if you need to do that step to solve it, please feel free to show all the work, do every single step. Okay? Does that make sense?
I was just being lazy to factors. But
Yeah, don't. I want to see you setting them equal to 0. Okay, do these 4 here. Okay, let's go ahead and do these. First one factored out. 2 numbers that multiply to give me 12. And add to give me -8. Y minus 6. Y minus 2 is equal to 0. -2 times -6 is +12. -6 plus -2 is -8. Set each factor equals 0. Y minus 6 equals 0. Y minus 2 equals 0. Y equals 6. Y equals 2. No, it's okay.
I know that. Just for your convenience.
Not worried. So let's just garage.
Yeah. think I will call it, because I heard that video. Show you your convenience.
Yeah, that's second one, I need to set it equal to 0 first. So I subtract 14 from both sides. So I get m squared plus 5m minus 14 is equal to 0. Two numbers multiplied to give me 14. It's negative 14 that had to give me 5 would be 7 and negative 2. 7 times negative 2 is negative 14. 7 plus negative 2 is positive 5. So m plus 7 equals 0. M minus 2 equals 0. M equals negative 7. M equals positive 2. The next one. Next one is the difference of two squares. C plus 5 equals 0. Sorry, C plus 5 times C minus 5 equals 0. C plus 5 equals 0. C minus 5 equals 0. C equals negative 5. C equals positive 5. And last one on this page. Negative 15, 14, that's 15 and negative 1. Divide by 5. I get d plus 3 and 5d minus 1 equal to 0. So d plus 3 equals 0. 5d minus 1 is equal to 0. D equals negative 3. And d equals 1/5. Questions? Okay, do those. Okay, let's go ahead and finish these up. So your first step on this one is to subtract 4 from each side. You get 4a squared plus 6a minus 4 is equal to 0. Everything is divisible by 2. You want to do that before you do your factoring. Divide everything by 2 to get 2a squared plus 3a minus 2 is equal to 0, and then do your factoring from there. You want to get your numbers as small as possible. If you can divide everything by a constant first, it makes your factoring easier. So I do have to set up the X box on this one. I get negative 4, positive 3, which is 3 and negative 1. Divide both those by 2. So I end up with 2a plus 3 times 2a minus 1 is equal to 0. Is that right? Oh, no. 4. Sorry, that's 2. My bad. So this is not right. I knew that couldn't be right. It would be 4 and negative 1, not 3 and negative 1. So I end up with a plus 2 and 2a minus 1. And so I get a plus 2 equals 0, 2a minus 1 equals 0, a equals negative 2, and a equals positive 1/2. Second one, I can divide everything, but it is a common factor anyway, so I'll call out the common factor of 2y. So I get 2y times y minus 3 is equal to 0. 2y equals 0. Y minus 3 is equal to 0. Y equals 0. Y equals 3. Those are my two possibilities. On this next one, set it equal to 0, subtract 4. 3w plus w squared plus 11w minus 4 is equal to 0. So I get negative 12 and 11. That's 12 and negative 1. Divide those by 3. And I get 4. So I have w plus 4. 3w minus 1 equals 0. W plus 4 equals 0. 3W minus 1 equals 0. W equals negative 4. W equals 1/3. The last one, divide everything by 3 first to get b squared minus 9 is equal to 0. B plus 3, b minus 3 is equal to 0. B plus 3 equals 0. B minus 3 is equal to 0. B equals negative 3. B equals positive 3. Okay. I know that many of you are tempted to shortcut, skip steps. Don't. Don't shortcut, don't skip steps. There is a connection between when you do the Xbox factoring and the answers here, go, oh, I know what the answers are, I'll put them here. Don't do that. Okay, this is not just about getting the right answers. This is about the process of coming up with factors and setting each factor to 0. I dare say that is actually more important than getting the final answer. Don't get lazy and try to, oh, I know what it is, I got to figure it out and go to the final answer. Do the steps, show the work. Set each factor equal to 0. That process is important because you will factor and set each factor to 0 even when you don't have this going on. This process works for all kinds of problems, not just polynomials and quadratics. All kinds of problems. And if all you do is think, well, I'll do the shortcuts here, you won't get the process down. And the process is as important, if not more important, in this case, than the actual final answers. Show the work. Don't skip steps by being lazy. I will mark you down, right answer or not, because I need to see this. I need to see this process. Okay?